Finite math. In this video, we're going to talk about the logarithmic functions. We're going to look at the graph of a log function, evaluate logs using a calculator, and then change exponential form to logarithmic form and back. As you go through this video, you're going to notice on the top left we have some icons. This icon tells us we're going to look at the process, some examples, a little bit of practice, and then what you need to do to get really good at it. Remember, it's not magic, it's math. So let's get started. The log function is the reflection of an exponential function about the equation y equals x. Here is the graph of y equals 2 to the x. Here is the line y equals x, and then here is y equals log base 2 of x. When it says it's a reflection, that means that they mirror each other. There's another really cool thing about this is the order pairs are in reversed, or I like to think of them as being exchanged. That means logarithmic functions are the inverses of exponential functions. Even more cool, let's look here. Do you notice for exponential functions we have y equals 2 to the x, and for log functions we have x equals 2 to the y. Yeah, we just exchanged the x and the y's. That's pretty cool. Common logs and natural logs. A common log is one that we're used to seeing, log of x. That's the same thing as saying log base 10 of x. If no base is indicated, the log is assumed to be base 10, and our calculator uses base 10. Natural log, or ln, we would say the natural log of x is the same thing as saying log base e of x. Now e is a specific number, 2.7181828. In another video, we will talk about carbon dating. To solve those equations, we will use the natural log to solve an equation with e to the x. Evaluate the following using the calculator, round to 5 decimal places. If you can't find your log or natural log key, search YouTube for the calculator type. For instance, is it a TI, is it a sharp, that kind of thing. And then also put in log or natural log key. I have 2 examples that you might want to look for on your calculator. All right, it's time to take your calculator and type log 3.51976. And you should get 0.54651. How about the log of 0.0978606? For that one, you should get negative 1.00939. How about the natural log of 326.55? Did you get 5.78858? And the last one, we want to find the natural log of 0.078242. Did you get negative 2.54795? All right, you have your calculator under control. Changing between log and exponential forms. On the left, we have a logarithmic form, y equals log base b of x. Next to it, we have the exponential form, x equals b to the y. Let me show you how they're related. X is the result of raising b to the y power. B is the base, and y is the exponent. And that's it. That's all you have to do to change from log to exponents and exponents to logs. So let's do a couple. Let's just review a second. My numbers, my bases, and then we have the exponent. The log base 6 of 216 equals 3. We're going to have 216 equals 6 to the 3rd power. And you can try that on your calculator. Do 6 to the 3rd power, and you should get 216. Log base 5 of 625 equals 4. For this one, we have 625 equals 5 to the 4th power. And once again, you can try that on your calculator. 5 to the 4th power should give you 625. What if I'm given 343 equals 7 to the 3rd? Well, that's actually no problem. We'll have log base 7 of 343 equals 3. What about this crazy number? 262,144 equals 4 to the 9th? Once again, it's not that bad. It's log base 4 of 262,144 equals 9. Now that we have it under control, you get to try these by yourself. Do this one first. Did you get 64 equals 2 to the 6th power? Try this one. Did you get 531,441 equals 3 to the 12th power? Then you are correct. How about this? Exchange this one to a log. Did you get log base 17 of 289 equals 2? And finally, try this one. Did you get log base 7 of 40,353,607 equals 9? And that's actually the end of the video. So what do you need to do next? You need to practice. Did you like the video? Why not like it? Did you really like it? How about you subscribe? Did it help you? Why don't you share it with a friend? Remember, it's not magic, it's math.